So if anybody asks any questions. So now we were on number 31. That being said, though, guys, if y'all would keep the noise down during it, it'll help out. What am I doing? It'll help out with people being able to hear it on the recording. Okay, 31. For FTH shown below, which of the following is an expression for y in terms of x? Well, what kind of triangle we got? Right triangle. Two things normally you can use in right triangles. One of them we've used so far is SOHCAHTOA. What's the other one you normally use? Pythagorean theorem, right? So can I use Pythagorean theorem here? Do I have three sides that I'm dealing with? One side, two sides, three sides. I don't know two of them, but I am dealing with sides. When do I bring in trig? What do I normally have to be bringing in trig? Normally to bring in trig, I need some angle theta. Okay, but I don't have that. So we're just going to deal with Pythagorean theorem here. A squared plus b squared equals c squared. They want to know y, solve for y basically. So plug this in and I'm going to get 4 squared plus x squared equals y squared. What do I need to do to solve for y? Square root both sides. And y is equal to plus or minus the square root of x squared plus 4 squared. And they don't have the plus or minus, it looks like. Oh, well, it's not going to be minus. Why? We're in geometry where everything is positive, right? In geometry, it's all positive, so x squared plus 4 squared would be e. E will be the right answer. Okay, next, number 26. This was 31, so probably somewhere around there we go. Okay, so absolute value. I'm going to do absolute value. I'm going to do everything inside because the absolute value is a grouping symbol. So this is going to be negative 3 times the absolute value of 2. And remember, absolute value does not switch signs. It just eliminates them. Okay? It doesn't care what the direction of it is, whether it's directed positive or negative. It just wants to know what the value is. Okay? So negative 3 times positive 2. And then that's going to be equal to negative 6.
I've never looked at it. So it just gets rid of
it just drops the signs. Now, don't drop the signs until after you do all the work. Do all the work you can, and then when you're done, if you have a number like 2, just drop the signs. There were no signs to drop, so I just put it back as 2 again. Yep. Well, you do the work first. So I had to put these together before I use the absolute value. So do the absolute value, the very last thing. And then 2 becomes 2. But this negative stays on the outside. It was never affected by the absolute value. All right, next is 32. Okay, a bag contains 12 red marbles, 5 yellow marbles, and 15 green marbles. How many additional red must be added to the 32 already in the bag so that the probability of randomly drawing a red marble is 3/5? Well, I'll tell you a way to cheat. You know the answer is going to have to be a multiple of 5 for it to reduce to 3/5. I mean, this is going to have to be a multiple of 5, right? I'm sorry. This is asking how many are going to have to be added. So the final number has to be a multiple of 5, but that's not how many have to be added. Like here, I could add 3 and get to 35, right? Or I could add 8 and get to 40. But that's just kind of a quick way to check it. So now what I want to do is figure out 3/5, and at this time I have 12 red marbles out of 32. 12 red marbles out of 32. What do I need to do? What do I need to add to the top and the bottom to get 3/5? Well, we could do kind of just a guess and check. That's an easy way to do it. Let's try adding 8 to both. Now that's 1/2. 1/2, is that bigger or smaller than 3/5? Smaller, so I need to keep adding numbers, right? So I could add another couple. Instead of adding 8, maybe I could add 5 more and get, that's 5 red. See, this is the number of red, and this is the total. So when I add, sorry that it freaks out like this. I hate this. I need an update to my software. But whenever it adds 5, it's adding 5 red, and it's adding 5 to the total. So this could be 25 over 45. Well, that's going to reduce to 5/9. That's not quite it either. So let's try one more time. I bet you this is going to do it. And so this would be 30 out of 50. Does that look like it's going to reduce to 3/5? All right, so how many total red marbles did we add? 18. Now, do you guys want an algebraic way to do this? They told you were going to add marbles to the top and to the bottom, right? Right now you got 12 out of 32, and I want to add some number x to the top and some number x to the bottom, so that when I'm done, I get 3 over 5. Y'all remember how to cross multiply? Cross multiply and solve. This and this, and I'm going to get 5 times 12 plus x equals 3 times 32 plus x. That's going to be 5 times 12 is 60 plus 5x equals 96 plus 3x. Subtract the 60 here and the 3x here, and I'm going to end up getting 5x minus 3x is 2x, and 96 minus 60 is 36. Divide by 2, and I get x equals 18. So, for you that like algebra and x's, there you go. If you want to guess and check, do the previous one. All right. Remember that any of this that you guys need, I'll put it up on my YouTube tonight, which I'll have to tell you guys how to get to my YouTube. Okay. Yeah, I started doing that with my kids in class, just working out half their homework problems on YouTube, and they like it. Well, I don't know if they're gonna pass, but they like being able to go in there and see the work. Let's see. Mr. Riley probably gets some of the best scores in our district, though. I'm telling you, all the technology and stuff can't make up for just years of experience that guy's got. Miss Thiessen gets great stuff too. We're telling you, man. All right, 59. Yeah, anytime you need tutoring. Tuesday mornings, Thursday afternoons, I'm here. Yeah, Tuesday mornings, Thursday afternoon. I can tutor on any algebra too. So in the equation, blah blah blah, m and n are integers. The only possible value for x is -3. What does m have to be? So they're already telling us that x is -3. If we know it, what do we do with it? Plug it in. Plug it in. Plug it in. Seriously. All right. So 9 minus 3m plus n equals 0. So let's just solve it and see what we get. Because I'm going to subtract 9 from both sides. And I got negative 3m plus n equals negative 9. Subtract the n, and I'm going to get negative 3m equals negative 9 minus n divided, and then I'm going to divide both sides by negative 3. Negative 3. So I'm going to get that m equals, and I'm going to go ahead and divide these. I'm going to separate these here, and I'm going to say negative 9 over negative 3. And negative n over negative 3. So this is like minus a positive n. As long as there's at least one negative between them, that's all that matters. I could put plus a negative n, doesn't matter. So m equals 3. And I'm going to cancel this negative over negative here and make it positive. So it's 3 plus n divided by 3. Now the question is, well,
It's impossible. It's gotta be like 3 or 6. I said we go C. No. You go C. No, B is better. It's cool. How about J first or last? Go A.
yeah, if they would have said consecutive integers, that would be better. They didn't give us anything to work with here. They just said they were integers. By integers, that just means that n has to be a multiple of 3. As long as n is some multiple of 3, 3 divided by 3 is a whole number. Integers just means whole numbers, positive or negative, right? So I could put a positive 3 in there and it works. I could put a positive 6 in there and it works. I can't put a 4, because 4/3 is not a whole number. So I agree with you guys that I don't think there's a definite answer for this. I think there is a group of answers called m equals 3 plus n over 3. I think this was maybe a mistake on the test. Possibly I'm not seeing something because, like I said, 59 is probably made to get those savant people. But I believe that if you tried many of these, you would get a correct answer. For instance, plug in 3. Let's just start with the first one. If I put in a 3 for m, then I can put in a 0 for n. And I get 9 plus a negative 9 plus 0 equals 0. That's true, right? What's 9 minus 9? 0 plus 0 equals? That's true. So A works. Let's try it with a negative 3. If I put a negative 3 here, instead of a positive, why did I do that? There you go. If I put a negative 3, so this is going to be 9 plus 9, so that's 18, right? Well, now if I just make n a negative 18, it works again, right? 18 minus 18 is 0. So I think that they should have put something like this. If they'd have put like consecutive, if they put consecutive in, so if they would have put down consecutive integers, which I think is what they meant to do, if they put down consecutive integers, then I believe the answer is positive 3. No, that can't be right either. I don't know, guys. I'll look at it, and if I can figure it out, I'll post it on the video. Okay. No. No. All right, what was the next number? 55? 57. Okay, if x and y are real numbers such that x is bigger than 1 and y is less than negative 1, then which of the following inequalities must be true? So if x is bigger than 1, y is less than negative 1, which of these have to be true? So really, what are we saying? X is positive, okay, and y is negative, okay. So let's just look at that first and see if we can eliminate any. Is a positive divided by a negative? This is positive, this is negative. Is that going to be bigger than 1? Because y has to be negative, right? So we can eliminate a. A positive absolute value squared might be bigger than the y. Let's see. If it's positive and I square it, will it be bigger than another positive number? We may have to look at this one. I think this one may be a maybe. I can't see a reason to disclaim it right now. It's actually going to be right answer. But, no, yeah, it'll be right. No, yeah. Yes, it will. Okay, sorry. C. So this is a positive number, minus 5, and a negative number, minus 5, right? So if I take a positive number and subtract 5, is that going to be bigger than a negative number, minus 5? Just pick any number. How about a positive 1 minus 5? That's negative 4, which we actually can't even use a positive 1, but let's just assume we could. No, we can use it because this would be 3 over 3. And then a negative 1 minus 5 is negative 6, right? But there's a possibility. Let's see. Could I ever make this one less than this one? What if I did 1.1 over 3 minus 5 and negative 1.1? Put this into a calculator. I think we're going to find out that the y is still going to be smaller. 1.1 divided by 3 minus 5. You know what? Let me just do this. I want to make it simpler. How about we let's get rid of these fractions. So if I multiply everything by 3, okay, so this is going to go away here, and I'm going to get x minus 15 is bigger than y minus 15. Look, if x is always bigger than y, then that's always going to be true, because x is always bigger than y. We have to have that because x is positive and y is negative. If you take somebody, if we have two people standing here, and I'm standing in the bigger position and he's in the lower position, and we both moved left 15 places, he's still going to be farther left than I am. Because I have no choice. X always has to be bigger than y. Because x is bigger than 1 and y is less than me. Okay? So this is not going to be true. Now here, once again, x is always bigger than 1. Well, if I subtract 1 from both sides, let's clear it and I'll see. So we said, let's multiply both sides by 3. and we get x minus 15 is bigger than y minus 15, right? Add 15 to both sides. Add 15 to both sides, cancel that out, and I get x is bigger than y. That is true. You're right. Yeah, no, I think I don't know why I crossed it out. That is true. Okay, so hold on. C is also true. I believe B is also going to be true. Let's take a look at this one. If I have x squared greater than y, since these are absolute values, no, you're right. This one can't be, because what if I made y like a negative 20, and this is a 2? So this one is not going to be true. This one, if I subtract 1 from both sides, then I get x squared is greater than y squared. Well, right, so this could be, I could plug in like a 20 here and a 2 here, and that, you're right, it wouldn't work. So this one would not work. And x to the negative 2 greater than y to the negative 2 is 1 over x squared is greater than 1 over y squared, which is still the same thing. If I make y smaller than x, then their final values would not satisfy. So this would not work either. Yeah, C is the right answer. Okay, I'm going to